Hey guys, my name is Adam, and today we're talking about Bitcoin again. So, I presented you BitMacoin, and I talked about my approach to this bot. And today I'm gonna show you the Jupyter notebooks for it, the training one and the testing one, and hopefully you will give me some suggestions on how I should approach this thing further. But a quick recap before that. So the essential idea is that bot should generate some money from day trading of exactly in the Coinbase. So it should grab some data from the Coinbase, use that to decide to either buy, sell, or do nothing with Bitcoins and Euros in the wallet. If you remember, I used two approaches for this. One was called neat, and the other one was deep coup. So the neat results were not so successful. However, the deep coup was quite a bit more better, and I decided to just use this approach and move forward with that. So this is what I'm going to show you today. So here you can see the Jupyter notebook for the BitMacoin training. And for the start, there's not really much to say. I just set up the environment. Then there is the trading module. And afterwards, there is a actual training module. So yeah, it's currently training as well because I want to show you some results and how it works. But with the magic of editing, I hope to be at the game 100 by the end of this video. So yeah, let's get into it. As I said in the start, there's nothing much to say. It's just the setup of the environment, connecting to Google Drive and things like that. Then the trading module is where the things start to be a bit more interesting. So we set up a class, TraderMan. TraderMan is gonna be our main object here. It's the equivalent of deep coup network agent, which are used in other examples that you can see online. The things that we set up at the start is the initial Bitcoin wallet. So the bot will have 1 Bitcoin at the start of every game, no Euros, and the trade tax, which currently in Coinbase is 0.5% for each trade. We set up other variables such as rewards, which we'll track to train the network. Some specific, these are basically the same in each example, so I don't really think I need to get into those too much. Yeah, so we set up the wallets, we set the closing price for the current time interval and the next closing price, to which we'll get into a bit later. The steps done is just a counter of how many steps the bot done, and the alt position, so where the money was in Bitcoins or in Euros. We define a few functions, so just to get the last action, so what the trade was, get the state to get the inputs to the network, so the inputs I showed you in the previous video. We can just quickly recap with that. These are just 15 price points from 2 minutes to 20 days, and these are average prices for that period, and then those are divided by the current closing price. So as I said, the getState function just gives the inputs to the network, which it uses to actually decide on what to do. Now, moving over to the getReward function. This one actually is quite used for the bot itself. It gets the current score of the bot. So it just tracks, the closing price. As I said, the next closing price, we'll get to that in set reward, but yeah, it tracks the closing price, it tracks in which wallet the money is, and then, just converts that to either Bitcoin or Euros, just to give you a score of how your bot is performing. Now the set reward function is a key function here. What it actually does is it's the incentivization function for the deepq agent. So if the bot performs well, the set reward function will output a positive score. If it performs poorly, it will be a negative one, and it's calculated in a following manner. So it determines the old and new score by the change of actions. So let's say the Bitcoin is now trading from Bitcoin to euros. So he has 1 Bitcoin in a wallet. So the old score will be the next closing price for the next period. For this particular bot, it's 1 hour. So the mean price for upcoming hour will be the old score as the bot had its money in the Bitcoins and Bitcoins fluctuate in price. While the new score will be the closing price, since the Bitmo coin is converting from Bitcoin to euros. So let's say if the price is 1,000 euros at this moment, the new score will be 1,000 euros, and the old score for the old action that Bitmo coin was in Bitcoins will be the mean price for the upcoming hour. What it does, it then just compares the two, subtracts the trading tax, and yeah, if it's positive and it's positive, if it's negative and it's negative, just, a delta of the scores. And yeah, if a bot just goes from euros to Bitcoins, then it's another way around. Next up, we have the step function. So this one is called each time the bot makes a decision. If it decides to trade in any way or just do nothing, this one still will be called as well. Network, just the basic architecture of the network. I borrowed it from the example with the snake that I already linked in my previous video. Nothing really much, just, 3 inner layers and an output layer with 3 classes, so buy, sell, or do nothing. Then remember, replay new, and train short memory are pretty much the same for most of the deepq agents. It's just a bit altered for this one to reset the wallets and the counts for the buy and sell. Now for the main part, the training model. I know it's quite a bit of code in one sitting, but it's a Python notebook. What will you do about it? So we have some variables that we set up. So the training data frame, obviously for our training data. Training len is just the length of the whole data set. Train intensity. So this one is quite important. 1440 means 1440 minutes, which is 24 hours or a day. This variable sets up the slices of periods that we will feed into the network for training. So network trains in games, and one game will consist of 1 day. Now, how that day will be selected, I'll get back to that in a bit of time. Now, reward period, as you can see in the name, it's Bitmocoin 1 hour. So I wanted to test 1 hour model as well. If you remember correctly, with the set reward function, we need a next close price. So this is where that next close price is coming from. So if the bot reward period is set to 1 hour, the next close price will be the following 60 prices for that hour. So for each minute, the price of that hour comes to a mean, which is the next close price, and which is crucial for training the network. Okay, so getting back to this, last possible line is just, the end of the data set. And games to play is for how many games you want to train at this particular training session. Then we have the game class. Nothing much, just initiates each game, selects the trader. Yeah, there's not much to talk about this one. Now the trader class. So this guy actually does the requests to the trader man, which we just reviewed above. So the deep cool agent. What it does some basic things as do move, which goes on and calls the step function here. And yeah, it updates the prices, the closing price and the next close price, and that's pretty much it. Oh, and sends an empty action for game not to crash, because with all my tryings to teach the network not to trade against its wallet, so if the network has Bitcoin, he obviously can't buy more Bitcoin, but still tries to do that. So I just send an empty step, and yeah, that's it. And I don't evaluate those decisions now. Now for the get records, yeah, it just checks the score, not much else. Plot CBurn, standard, initialize game. This one starts the game, so the game can start at random, meaning the bot can start the trading day in either Bitcoin or in euros, and it happens here. It's just a random, and that's it. Yeah, and that just sets up the main variables and initiates the game. So run. Yeah, the main part of this notebook. We just set up some variables that we need. So we create an agent, set the counter of the games, the scores for the plot, and the closing price, not closing price, just initiate the game. This is just a while to see how many games we're playing for now, and end it at the game that we prefer to end it. Yeah, now here. So we initiate the game itself. So for game 1, we'll try to get an init line. So it's just a random line, well, not a random line, but random observation from the training data frame, which we use for us to determine what kind of day the bot will have for this game. So just a random day selection for the bot to train on. The end line just specifies when the day ends, and yeah, we set a line variable afterwards. Again, you can see that the closing price and next closing price are things that really repeat within the codes. I guess I could optimize on that, but yeah, I just didn't for now. And then we just initialize the game using the initialize game function. We set up some trackables that we want to track, and we introduce some randomness to the games. So what this does is sets the models in such a way that it would only make its own decisions and not random ones for the last 3 games in each 10 of the games. So from 8 to 10, those are just the decisions of the bot. The first 7 can have random influences, and yeah, just to give some randomness to the bot for it to have, different situations and different states to evaluate, so it could learn better and not just stick, to one strategy as we had with NEAT, where it doesn't trade at all and just, tries to be safe and do nothing. And then we start. So each day we'll have 1,440 observations. We just cycle through those, and for each observation, we check if the epsilon is true for that observation to be a random move. If it's a random move, then there's a random move based on the wallet of the bot. So if the bot has Bitcoins, it just exchanges that to euros. If it has euros, it exchanges that to Bitcoins. And if the epsilon isn't true, it just goes for the actual prediction, calls up the model, predicts what to do, and then you have the final move here. So the class, what it's gonna do, and does the move, and updates the prices as well at the same time. These are just to have a better visualization what the bot does during the day. So not that important. Then we update the state for the bot to train later on. So the bot trains here and remembers the states here. And that's pretty much it. Gets the record, so what's the game score currently, and prints out some data that I just wanted to track, and it's just, easier to see how it performs, how it does during those days. Yeah, other code is just pretty much plots, and yep, that's pretty much it. So the training process goes like this. You just have these printouts and terminal, I guess this is how it could be called. So let's take a non-random game like 20 or so. Yeah. So yeah, as you can see, it states at the top here what it started with. So the bot started with euros. It states the number of the game, selected lines, so the first line and the last line of the day, the prices for that day, so this is the first and this is the last one, you can see that clearly in the graph. Then the euro amount of both wallets at the end of the day, the Bitcoin amount of the both wallets at the end of the day, so this equals this. It's just an expression to be a bit easier to track, since, the price fluctuates quite a lot. Calculates the steps done during the training process. So did the game crash? Well, I had a crash mechanic before, so that's just the leftover from there. Then how many times the bot bought and how many times the bot sold, and then total done, so just 61 divided by 1439, and the random steps done. So you can see that for 10th, 9th and 8th game there's no random steps, but if you would go to game 17 there's 207. Yeah. So as I said, from games 1 to 7 included the bot makes some random, not the bot, the code makes some random decisions just to play around a bit, get to a bit more different states. And from game 8 onwards to 10, the bot just tries to do its best and beat the market. So now if you would look at the results, you could see that, but that's lower than 1 Bitcoin, so it lost some money here. And yeah, it did. And the thing is, each trade costs 0.5% to trade. So each line of these is a trade, and that costed money. So the problem now with the bot is that it trades a bit too much, but we'll go to the solution of that and when we switch to the testing notebook. So regarding the lines, just a quick note here. The blue ones stood up when the bot buys, and the orange ones, yellow, orange ones, are the ones where the bot sells. So you can see that, it gets the dynamic of the curve. So it buys at low and sells at high. So yeah, the results are, quite good. Not astonishing in any way, but quite good. And at the end of every 10 games, you'll see a graph like this, which just, points out how the bot performed during those 10 games. And then at the end of the session, you'll have a graph for all the games. But we'll get back to that when it finishes up, hopefully in
One eternity later.
So it has finished up running and now we have the results. And as you can see, it doesn't really strike that many times above a score of 1 Bitcoin. And as I said, in most cases it is just due to over trading. Like, just check this one. In one day it made almost 300 trades. So yeah, like, it's no wonder that it loses money, because it just loses that on the trading tax. But as I said, we'll get back to that trading tax issue and the trading frequency in the testing notebook. So back to you, future, past, Adam. Now for the testing one. So I don't really have much data. And hopefully I'll do the testing part next time on real Coinbase API. Since the prices are public, I don't really need to trade to get the prices. Yeah, so this notebook is pretty much exactly the same copy of the notebook before, just with some things changed, which isn't really that much. So we initialize the environment, connected to the drive, set up the same variables, then set the network we are going to use. And this is from try 7 4 hours, because this one performed quite well. This is just why I want to show this one instead the 1 hour one. Yeah, so it's all the same, works pretty much the same as well. But what it does is a bit different here. So how it approaches the problem and how it, works out how much money it will make. So for the trade intensity, we just set the testing period that we want to do. You can see that I'm using the same data, which is just awful, but yeah, hopefully we'll switch to real data quite soon. So the trade intensity here set is 7 days, so 7 times the amount of minutes in a day. The reward period is set by the model. The model I'm using is a 4-hour one, so I set 4 hours for the reward period. And what it does with those 4 hours now, it's not just for the reward tracking, but actually it tracks when the decision was made and if the bot can make a decision. So the assumption here is that if the bot trades, it can't trade for upcoming 4 hours, which I know sounds awful, but I just couldn't really solve this in any other way for now. Like, I'm thinking of ideas how we could wait just the last decision and see if it, could get even a better result with additional trade during the reward period. So if the reward period is 4 hours and the bot just made a trade like 2 hours ago, it could just try and see if the new trade will improve that result, not in 4 hours again, but in the 2 remaining hours that it has from the decision that it made. So yeah, this is one of the ways that I'm thinking of solving this issue of just trading every 4 hours. And it doesn't really trade every 4 hours, it trades when it needs to, but yeah, the most frequent it can trade the 4-hour model is each 4 hours. And in the code, you can see that right around here, I set up a time counter. So just counts the time passed from the last trade. If the time passed from the last trade is lower than the reward period, so in this case 4 hours, it can't trade. It just goes to else and misses the whole thing of trading. And yeah, I tested it for a couple of weeks. This is one of the better results I got, I'm not gonna lie. There are one week when I traded and got the result of 0.86 Bitcoin at the end of the week, and not really much gain in money. Well, because it's, different valuation, I guess we should track the euros a bit more here. So here I traded for a week and made 300 euros, almost 250 in a week. And it only did 16 trades in total. And as you can see from the spaces between the trades, not all trades are made in 4-hour intervals. And yeah, that's the current result of it. And my next plan for it is to actually set it up and connect it to the Coinbase API, the public one, and let it like fake trade. So just, trade within the model, or perhaps I will just, connect it to the API. I have an account so I can trade with that. And and see how it does with real live data, how the response time is, if it can act fast enough, things like that. So, yep, I guess that's pretty much it for today. I don't really know. I guess I'll upload the notebooks to GitHub. Yeah. For you to check on it, you can play around with those and see what you get. Upload both of these, so yeah, feel free to play around. If you have any suggestions regarding my reward period span problem, because like using the 1 hour model, the reward period is 1 hour, so bots technically can trade each hour. And I'm thinking of doesn't really, cost much time to change this, because it's just, wait a sec, this block. Yeah. Because it's not really much coding involved here. I just need to change this for trading sessions, and that's it. Yeah, so I'm thinking of trying out to train a 15-minute bot as well, and 10 minutes, just to see like what interval works best. And yeah, at this point I'm not really sticking to any of those. I tested 8 hours, that's a bit too much, and 4 hours seem to be quite okay. 1 hour is okay as well, but yeah, I hope I didn't lose you here. So if you have any ideas how to approach this problem of 4 hours, like some depreciating weight from the last trade or something like that, feel free to leave a comment. And yeah, hope to see you soon. Bye.